What is this? Oh my goodness. Let's be real honest. You know most of this. We're just going backwards. We dealt with this in the previous page, and now they're a little more formalized. If you read it this way, you're taking a derivative. If you read it this way, you're taking an antiderivative. For example, the derivative of sine is cosine, so the integral of cosine is sine. You know this. There are some of them that are very new, and some of them that are a little bit old. Some of them where you know it, but the signs look a little bit off, like the derivative of cotangent is negative cosecant, so they put the negative over here, still works out. We know about arcsine. Notice that there are a couple with arcsine, and there's a couple with arctan, and then there's the arcsecant things. Now, arcsecant is not tested in AB or BC. It's good to know, but you don't have to hang this one on your refrigerator. We're not going to make note cards out of that one. But I want to point out these that have the U's and the A's in there. The variable U is used as a placeholder when you have a composite function. So even though we know these, the arcsine and arctan, and we're now kind of working backwards with them, this is going to come in handy when we get to something called U substitution. Okay, so this is like what you learned. This is generalizing it when there is a composite function. Okay, so starting at the top, you've seen it, you've seen it, you've seen it. It's a little unfamiliar. You know it, you've seen it. Unfamiliar, familiar, familiar. It's familiar because of derivative rules. And then there's the rest of these. So we're going to have to learn and memorize these. This is a good reference sheet.